I'm back. All right, flip to page 13. All right, we are going to evaluate one-side limits from a graph. All right, so we can also figure out limits from a graph. So here we go. So first of all, look at the function value at -4. It just wants to know what's the function value at -4. So when you go to -4, there's an open circle, so it does not exist. All right, so technically right there at -4 doesn't exist. Now let's look at the limit of our function as x is approaching -4 from the left. So from the left, that little negative means I'm putting my finger here and I'm going towards -4. The function's value is going towards 2. All right, part C, the limit as x approaches -4 from the right. So I am taking my right hand, I want to see what's happening here. So the function's coming in at that same function value 2. So that means the limit as x approaches -4 from both sides exists. It's the same number, so it's 2. These problems, we're all looking at what's happening at the function at -4. Now, since there is a hole here, I just want to talk about this value. This function is not continuous because there's a hole there. That does become important a little bit later in the unit and in calculus, whether a function is continuous. So that's why I'm having you evaluate it at a specific value, and so we can start to talk about if it's continuous or not. All right, E, G, H, and I should also be separated. This thing kind of copied weird. All 4 of those go together. So, problem E wants to know what's the function's value at 1. So now we're looking, where does x equal 1? We're looking along my red pen line. So the function's actual value, I have a open circle, so it's not defined there. I have a defined value here. The function's value is 4. And then here's the reason why. Let's look at the limit now as x approaches 1 from the right. So as x approaches 1, so again we're looking here. We want to see where is a function touching this line at 1 from the right. So I'm down here. It is approaching the value -2. So the limit from the right is -2. Let's look at the limit as x approaches 1 from the left. So again, I'm seeing what's happening along this red line from the left. So from the left, I'm coming in, the function's value is 4. These do not equal each other, so the function at 1 does not exist. Okay? So even though the function has a value at 1, the function's limit at 1 does not exist because it's not the same from the left and the right. All right, question F. Let's look now at point 6 when x is approaching 6. So you're looking here. What is the actual function's value? I have a filled in circle, so the value is 2. You have a closed dot at 2. Now go down to J. What's the function's, what's the behavior of the function as x approaches 6 from the left? So I'm looking here, a function is approaching from the left. Its value is going to be 5. Sorry, I got to keep flipping up and down. All right, so let's see what happens as x approaches 6 from the right. So again, from the right, it is approaching 5. Since these two are the same values, the end result, the limit as x approaches 6 of your function does equal 5. All right, so here was the final answer when you're looking at 6. Here was the final answer at 1, and the final answer at -4. Okay, so now you try. Again, if you want to pause it and do this on your own and then come back and check, that would be great. But I'm going to keep going. So this is going to be defined to be function h. This actually should have been somewhere on your paper that's function f. Wasn't really written anywhere. So now we're looking at function h. All right, we want to see what is the limit as x approaches -4 from the left. That value should be 3. All right, we want to see what happens as we approach -4 from the right. The value is -2. So altogether, since those are not the same, the value does not exist exactly at -4. That's the answer. This wants us to figure out what is the actual function's value at 4, not the limit. Just is it defined? We have a closed dot, so that answers 3. But again, since these two weren't the same, your limit does not exist. All right, so those 4 problems went together because we were all looking at the function, as x approaches 4. All right, I'm sorry, -4. Let's look at these 4. Let's see what happens as your function approaches -1 from the left. So I'm looking here. From the left, my function value is +4. All right, look at it from the right. So here from the right, it's coming in. The function value is also 4. They equal. So the limit as x approaches -1 is 4. Now what is the function's value at -1? That one is also 4 because there's a closed dot there. So it's continuous at 4. All right, the last 4 problems want to see what's happening at 2. So the function value at 2 from the left, the function value is -1. The function value here from the right is +5. These are not the same value, so your limit at 2 does not exist. But just evaluate the function at 2, that answer is -1. All right, here's more practice for you to complete. So get out your textbooks, do those problems, practice this. There's not that much practice in this packet. You need to be doing the practice problems every day you finish notes. Very important. All right, have a good day. Goodbye.